Hello, the topic of today's lesson is to continue studying quadrilateral shapes. To be more specific, we're going to focus our attention on parallelograms. Let's review what it means to be a parallelogram. Parallelogram is a quadrilateral, we know that, where it's such a quadrilateral where opposite sides are parallel to each other and also happen to be equal to each other. In a parallelogram, opposite sides are parallel to each other. We have two pairs of parallel sides. So an interesting theorem comes out of this with certain proofs that you will learn in high school. Opposite angles of a parallelogram are equal. Opposite angles of a parallelogram are equal. Therefore, angle A equals angle C, and angle D equals angle B. Angle D equals angle B. You can make an interesting experiment by cutting the parallelogram along this particular line, cutting line, and then as you flip and rotate the two pieces, the B and D will become congruent, which is a word in geometry we use for sameness. B and D are congruent, and angles C and A are congruent, which is the same thing to say as to say they're equal to each other. So another interesting theorem, there are three. So the first theorem is the opposite angles are equal. The second theorem is that angles between neighboring angles between two parallel sides add up to 180 degrees. Again, another interesting theorem is that angles between two parallel sides add up to 180 degrees. Let's identify an example A. Side CD is parallel to BA. Therefore, we have two angles between two parallel sides. We have angle D and angle A, and together D plus A add up to 180 degrees. We also have another pair of angles. C and B, which are between two parallel sides, right? Let's label their parallelism with these birdies, with these little arrows. And therefore, we do know that, I don't have a pink pencil, C plus B also must be equal 180 degrees. So this is theorem number two. That neighboring angles, angles that are next to each other between two parallel sides, must add up to 180 degrees. Another variation, we can split the parallelogram vertically, just so, right? We can split it vertically. And again, we do have two parallel sides. I'm going to label them with another colored pencil. Let's do like light yellow. So AD is parallel to BC. And therefore we have neighboring angles, A and D and C and B. So angle A and B and C and D both add up to 180 degrees. So let's use these two theorems. Opposite angles in a parallelogram are equal, and neighboring angles between two parallel sides are add up to 180 degrees. So if this angle is 180, angle X must be 180. Why? Because they're opposite, and we know that this is a parallelogram. Now, if we have two neighboring angles, adjacent they're called in geometry, angle that measures 120 and angle Y. Yes, are these angles located between, I can draw the other way, between two parallel sides? Yes. We do have two parallel sides, just so. Therefore, these two angles must add up to 180, making angle Y be 60 degrees. And finally, again, we have a parallelogram. All three shapes are parallelograms, and we have this blue side and this blue side. They are parallel to each other, making this angle and angle Z being neighbors. And we do know that angles between two parallel sides in a parallelogram add up to 180 degrees, making angle Z being equal to, of course, 65 degrees. Now, let's try the following page where we have more interesting examples. Problem number 6. In the figure ABCD is a rectangle. It's very important to read English in geometry and understand what is given. Angle DAC, angle DAC. What is DAC? It's from D to A to C. It's this little angle, this little piece is 26 degrees. Find the complementary angle BAC. Well, we do know that because it's a rectangle, angle BAD equals 90, making this 90 minus 26. The complementary piece has to be 64 degrees, and we label the angle inside the shape very neatly, just so, 60 degrees. Next, number 7. It is very important to read the instructions. Find the unknown marked angle in each rhombus. These 3 blue shapes are all rhombuses. So we have missing angles X, Y, and Z. What do we know about opposite angles in a parallelogram? We know that they are equal. Opposite angles in a parallelogram are equal. Therefore, if one is 60, the opposite one will be 60. And because they're rhombuses, we can use the small dashes indicating equal sides. Now, we also know that rhombuses are parallelograms. They're just special. They're special parallelograms whose all 4 sides are equal to each other. Now, because they're parallelograms, we can find the missing angles. If we have 2 neighboring angles, 2 angles next to each other, between 2 parallel sides, we know they must add up to 180 degrees. Therefore, angle Y here is 50 degrees. And finally, because these are rhombuses, right? They're parallelograms with all equal sides. We can also consider just this triangle, this left triangle. And this triangle alone is isosceles. And we know that in isosceles triangles, angles opposite the equal sides are also equal. Therefore, angle Z must be 55 degrees. Now, problems number 8 and 9 are about trapezoids. It's important to read the instructions. Number 9 is we have trapezoid. In example 8, we have also a yellow trapezoid. What does it mean to be a trapezoid? At least one pair of sides is parallel. Let's label. It is given that AD is parallel to BC. It is important that you guys see AD and BC are 2 parallel sides. What do we know? Angles in a parallel, not a parallel, 2 angles, each pair of angles between 2 parallel sides add up to 120 degrees. So that means that if this is 120, let's pick up. That means this angle, 2 neighboring angles between 2 parallel sides must add up to 180. This must be 180 minus 120 equals 60 degrees. And we also have the other 2 angles between 2 parallel sides, angle that measures 50, and this one must be 180 minus 50 equals 130 degrees. Oh, here it is. Step 1, step 2. The solutions are right there. Now let's take a look at the green trapezoids. And we do have, again, missing angles. We have missing angle A, missing angle B, and missing angle C. I'm not going to focus on an easy example for angle A because I hope you see that we do have 2 parallel sides, just so. And neighboring angles between 2 parallel sides must add up to 180 degrees, making angle A to be 55 degrees. 125 plus 55 is 180. Now, similarly for angle B, right, we do have also parallel sides. Parallel sides just so, they're labeled with these arrows. And we do know that neighboring angles between 2 parallel sides must add up to 180 degrees, making angle A being 180 minus 68, not A, B, sorry, and it is 112 degrees. Finally, example C is a little bit more tricky. We do have, let's mark the parallelism. We have the top side is parallel to the bottom side. So there are multiple ways to take a look at this problem, but to find angle C, I think it's important to realize that we have two equal sides in this isosceles triangle right here. We also have an isosceles triangle. And because the two sides are equal, we do know that angles opposite equal sides are 50 degrees. 50 plus 50, therefore this piece has to be 180 minus 50 times 2 equals 80 degrees. So this piece is 80 degrees. Well, how does it help us? How does it help us? Let's think about it. We know that angles between two parallel sides, actually we didn't have to find this. We know that angles between two parallel sides must add up, neighboring angles must add up to 180. Therefore, angle C plus angle 70, right? Let's write it down. Angle C plus 72 degrees equals 180 degrees. Therefore, angle C has to be 108 degrees. We are talking about neighboring angles between two parallel sides. In a trapezium or trapezoid, we have only one pair of parallel sides. I hope this helps in your journey of finding unknown angles.